It's gonna take a long time to get to space, isn't it? Cool. Okay, so I put up a poll on Twitter saying essentially, if I were to watch a sci-fi movie, which one would you like me to watch? And kind of by a landslide, Interstellar won. So Interstellar is a movie that I saw in theaters when it first came out in 2014. So I haven't seen it in 8 years. So this is kind of like a first watch for me. I don't remember a ton of what happens in it, and we'll watch it together and I'll talk about the science or the lack thereof, depending on how it goes. Let's go.
Not very scientific, Murph.
You said science is about admitting what we don't know.
Just got you there.
Okay, that's super cheesy, but it's important. I think it's an important thing to acknowledge that, yeah, science is all about what we don't know and trying to figure it out. Without our gaps in knowledge, there wouldn't be science. It's very okay and normal to not know or understand everything.
Faster, Tom, I'm losing it. Right at it.
Can you hack into a drone like that? Like, is that actually a thing that could be possible one day? I don't do this sort of science, so somebody let me know. That's potentially really terrifying.
And where's that money go? There's no more armies.
Well, it doesn't go to the university.
Even in the future, education's underfunded. It's probably one of the most realistic things in the whole movie.
You don't believe we went to the moon?
I believe it was a brilliant piece of propaganda.
As soon as they brought it up, I knew they were gonna go the fake moon landing route, but I can't believe they went the fake moon landing route. Oh my god. For the record, the Apollo landings, not faked.
And if we don't want a repeat of the excess and wastefulness of the 20th century, then we need to teach our kids about this planet, not tales of leaving it.
I know this is like right after, but I kind of agree. Like, I think it's still really important to fund scientific research and space exploration, but I think that we also need to focus on this planet and living sustainably here before we focus on things like colonizing other places. I think that there is a valid point to be made about not focusing on colonization necessarily as a important thing to fund money into. Looking at you, Elon Musk. Sorry. I got something in my throat.
Gang, let's mask up.
Look, they knew to wear masks. How hard is it? I'm just saying, protect yourselves. Protect yourselves, people.
The ghost.
How does that work? Here's the thing. Getting gravity in like thin strips like that is not possible in the way that we understand gravity. Gravity is caused by the curvature of space-time. You have a piece of fabric, you put a bowling ball on it, that bowling ball bends space-time, and you get trapped in that little indent, and that's what gravity is. So what would be causing gravity to be stronger in lines and patterns like that? Like, I get that it's an anomaly, but scientifically, under general relativity, that's not really a thing. Like, you could do that with magnetism really easily because it acts on those kind of smaller scales and you can set it up to be sort of whatever shapes you want with magnets, but gravity acts uniformly because it's coming from that one mass. Am I overthinking this? Am I overthinking this anomaly in a sci-fi movie? I think I'm overthinking the anomaly in a sci-fi movie.
We're not meant to save the world. We're meant to leave it.
Here's the thing about that not meant to save the world, we're meant to leave it line. I don't like it. I just personally, now, this movie doesn't make it clear what's causing these blights that's making it impossible to live on Earth, but I am just of the opinion that the priority should not be an escape route ever. Especially given that pretty much all climate change is human caused. And if we do end up going somewhere else, we're just going to repeat the same mistakes down the line. So I get how this is an extreme circumstance in this movie. I just don't think I personally like it.
Saturn. A disturbance of space-time.
Hit a wormhole.
So here's a wormhole. We got there. I knew we were getting there. Here's the deal with wormholes. A, they are highly, highly theoretical. We've never, ever seen them. They are essentially a shortcut through space-time. Normally, to get from point A to point B, you have to go across space. But a wormhole gives you a way to kind of like bend that space and take a little shortcut, right? Couple of issues. One, there's no way of knowing if they would be big enough for humans to go through. A lot of people argue that if wormholes exist, they would be really microscopic. Two, a wormhole, there's not any reason that it would have gravitational anomalies associated with it like what this movie is portraying. Like in one house. I know it's aliens, I know there's like some higher force thing, that's what they're going for here. I just don't like that they're using the wormhole as like a gravitational anomaly thing.
The Lazarus measures.
So another big part of the premise of this movie is the ability to control or modify gravity, which is probably the most fantastical thing about this movie so far, in the sense that it's one of the holy grails of modern physics, trying to find a way to control gravity, particularly through maybe a graviton, a fundamental particle associated with gravitational force, much like the photon is associated with the electromagnetic force. Because if we could do that, then we can combine the large-scale worlds of relativity with the small-scale worlds of quantum mechanics and particle physics and create a unified theory of physics and the universe, which is so cool. And the fact that that is something that they're almost there at in this movie is really amazing. So that's kind of cool. The issue is that some people don't know if that's actually possible. Like, if you could ever control gravity or modify it at a small scale, because our understanding is this large scale warping of the fabric of space-time, so having individualized gravities is tricky.
Near a black hole. Time's gonna change for me.
Yes, so the time dilation, this is something that I do really remember, and I remember this movie doing really well. So I'll talk more about it when we get to it. But like he mentioned, this is a kind of artifact of relativity. When you travel fast, or when you are near a really, really strong gravitational field, you experience time differently than someone who is not doing those things. And this double watch thing is a great way to show it. So I'm excited to get into that. Also, we're 40 minutes into this movie and there's still no space yet. Can we get to the space, please? This is a small thing, but I feel like you wouldn't want to launch a rocket indoors around glass windows. That's all.
A giant, sarcastic robot. What a great idea.
Was that a Marvin reference? A giant, sarcastic robot? At least he's not depressed. So I know I was all eager to get into space, but something you should know about me is I am actually really scared of space and space movies. And the fact that they're building up super dramatic music right now is not making me happy. I am not ready to be stressed out about being in space yet. It's too early. Gotta save that for the climax. Can we just safely dock, please? Why? Why did they put the dramatic music? For nothing. Entirely unnecessary. Okay, we have reached the artificial gravity of the spacecraft. I forgot the name of the spacecraft, but this is a very common thing in a lot of sci-fi shows. The basic idea is, if you have ever been at a carnival, at one of those spinny things where you get strapped to the wall and you're standing on something and then it starts spinning really, really fast and the floor falls away and you stay pinned to the wall. That's exactly what's happening here. It's an example of the centrifugal force, which isn't really a force, it's like the inverse of the centripetal force. But when you have an object rotating, there is a force towards the center, and with Newton's equal opposite third law, there's also a force out towards the edge. And so if you are in this spacecraft, you feel that force to the edge. So there's this artificial gravity created along the edge of the spacecraft. Now, there's a couple things that make this difficult to do in real life. The first is nausea. If you're in a spinning thing, there's worry about like what it would do to the inner ear of a human, dizziness, those sorts of things. There's also the construction of it, how you have to make sure everything is really sturdy, can withstand these rotating forces, and you have to have a lot of fuel and power to keep this thing rotating at a constant speed, because if the speed of rotation changes, then the amount of gravity you feel also changes, which makes it very impractical to work on. So it is a theoretical possibility, and it's a favorite thing to use in sci-fi shows, but there's just a lot of reasons that it hasn't actually been done yet in any sort of space station.
So a wormhole bends space like this, so you can take a shortcut through a higher dimension.
That's what I said.
What's a circle in 3 dimensions? Sphere. Exactly. Spherical.
I just want to say with this whole wormhole visualization, that logic of it would be a sphere, with something like a wormhole, it's such a weird construct in how it manipulates space-time that we really have no idea what it would look like. This is a bit of a better visualization, like the weirdness of it. That was pretty cool. I mean, like, with all of these things, any sort of wormhole travel, we have no idea. So you might as well make it look cool.
And that planet will slow our clock compared to Earth's drastically.
Oh, I bet.
Well, every hour we spend on that planet will be 7 years back on Earth.
Let's talk relativity. So when you have something like a black hole, it severely warps space. Space is normally like this, you put a black hole in it and it does this. And space and time are connected. That's a huge central part of general relativity. So when you warp space, time warps with it. And when you get in strong gravitational fields like this, your clock is going to slow down. Now this is something that we've actually measured here on Earth. If you have a really, really precise atomic clock and you match 2 of them up and someone stays at the bottom of a big mountain and someone else goes to the top of a big mountain, the one at the top actually goes a little bit faster because the one at the bottom is closer to Earth's core, and so it's feeling a stronger gravitational pull. This is something that we have measured experimentally. But Earth is pretty small, it doesn't have a super strong gravity. When you're near something like a black hole that has a really, really sharp gradient in gravity, now you wouldn't need a super precise atomic clock to measure those changes in time at the top and the bottom of the mountain. The changes would be huge. Like in this case, 1 hour equaling 7 years. Okay, let's talk about the black hole. So I'm a little confused, to be honest, because at one point he said, you know, this is a remnant of a dying star, and black holes that form from the death of stars are only a few times the mass of the sun. And black holes that big won't have an accretion disk. They won't have all that glowing stuff around because there won't be a ton of stuff that it can feed on. So the glowing regions around a black hole, what we call its accretion disk, are caused by the gas and dust and everything that's in the process of falling in that moves pretty fast and heats up and radiates, and so you get energy output. Now, if it's formed from the collapse of a star, first off, there's probably not that much stuff in the vicinity besides just the star. So you don't have as much to eat. And second off, if there were stuff, there would be less, so it'd be harder for it to be moving faster and glowing. Gargantua in Interstellar. Yeah, okay. So it's about 100 million solar masses. So it is supposed to be one of these super, super massive black holes, which tracks. it's just kind of unclear. The other thing is, we have only ever seen these types of black holes in the central regions of galaxies where there's a lot going on. Creating habitable planets around a black hole is a very interesting concept. Now, I'm no expert on what habitable planets would mean around a black hole, but it seems a little bit unlikely, and it seems especially unlikely how close some of these are to a black hole of that size. Very cool depiction of it. I like it. I think it's visually interesting. It tracks for being a supermassive black hole. Doesn't track for being in the center of a galaxy. If it was, you would see way more stars around and there would just be more stuff. So that's a little weird. We haven't ever seen these supermassive black holes not in the center of galaxies. And the planet thing is a little weird. Okay, back to it. Another fun fact about me, not a fan of tsunamis, very scared of dying in the ocean. Nope.
I've waited years.
So this is actually like an interesting thing because a lot of people ask about time travel, and with time dilation, you can time travel. That's what they're doing. They are going to the future. They are moving forward in time without experiencing aging the way other people would. But with time dilation, it only works one way. You get close to gravity and time slows down. I will say this movie does a really good job of humanizing the impacts that long distance space travel could have on humans. Could you imagine being by yourself for 27 years and just a hunk of metal? This movie's really good for that perspective.
A few moments later.
This movie's getting intense. It's good, I get it, but I'm like halfway through. I feel like I've been through emotional whiplash. Okay, back at it. Should I do The Martian next? I kind of think I want to do The Martian next. Okay. Ah! I'm sorry! I got caught up in it. I have nothing to say about the science. It's just a good movie, okay? I'll come back if something interesting scientifically happens, but otherwise, I'm just gonna enjoy this. I don't like this. It's debris. No. Oh God.
I have a plan. We let Gargantua pull us down close to her horizon, then a powered slingshot around, launching us towards Edmund's planet.
When it comes to this slingshotting maneuver, now slingshotting is something we do all the time in space exploration. We do it whenever we send things to faraway planets. It's just a really useful way to get a little gravity boost as we go around something. Doing it around a black hole is definitely possible. If you stay at a safe distance, you can treat the black hole like any massive object. It is not a cosmic vacuum. You only get trapped in it once you go past a certain point, and outside of that certain point, it exerts a gravitational field like any other. If the sun was replaced by a black hole that is the mass of the sun, we would just keep orbiting it like normal. We would not get sucked into it. So, obviously at the end of this movie, Cooper falls into a black hole. And this is where we reach the realm of complete speculation and very, very fiction part of science fiction. Realistic things, he loses comms, you can't get signals out of the black hole. Unrealistic things, everything else. But again, that's not really the fault of the movie. This is speculation, that's part of it. It's just worth pointing out.
Complex. They have access to infinite time and space, but they're not bound by...
Yeah, so all this stuff about gravity crossing dimensions, including time, it's a great plot point, just not in our current understanding of the universe, especially because the idea of multiple dimensions is still highly, highly, highly theoretical, and not something that we even know exists or not. All right, just finished it. It's a good movie. Like, I get it. It's a good movie. Yeah, do I have any closing thoughts? I mean, I really enjoyed it. It's really good about a lot of things scientifically. I know they did have an astrophysicist as part of the writing process and on set, so that is lovely. You know, there's always a couple things in sci-fi, but I can tell that they tried, and that's really awesome. I'll probably do a couple more of these. I think as of now, the vote on Twitter has The Martian as second top pick, so we'll get around to that at some point probably. And if there's any other ones that you're interested in me watching, let me know. As always, if you enjoyed this, press that like button, hit that subscribe, ring the bell, leave a comment, do all the things so that more people see my videos. 'Cause YouTube.